The question is, calculate the viscous force acting on a raindrop of diameter 1 mm falling with uniform velocity 2 meter per second through air. The coefficient of viscosity of air is 1.8 into 10 raised to minus 5 Newton second per meter square. So in this question, we have to calculate the viscous force here acting on a raindrop of diameter 1 mm falling with uniform velocity 2 meter per second through air. So see here, this is a raindrop here, and this raindrop having a diameter of 1 mm. So we will take diameter as d here, and this raindrop is falling with a uniform velocity 2 meter per second through air. So this raindrop is falling through air with uniform velocity 2 meter per second. So we will take velocity as v here. We have to calculate the viscous force which is acting on this raindrop. So first of all, we will write, given here, we have to find out viscous force, that will be denoted by F here, acting on a raindrop of diameter 1 mm. So diameter is given, that is 1 mm here. Next, uniform velocity is given, that is v is equal to 2 meter per second. The coefficient of viscosity of air, that is eta, is given, and it is equal to 1.8 into 10 raised to minus 5 Newton second per meter square. Next, we will check the units here. So unit of velocity is meter per second, unit of coefficient of viscosity is Newton second per meter square, but unit of diameter is mm here. So we will convert this in meter. So we can write d is equal to 1 into 10 raised to minus 3 meter. 1 into 10 raised to minus 3 meter. So see here, as we have to find out viscous force acting on this raindrop when the raindrop is falling with a velocity 2 meter per second through air. So this is the concept of Stokes law. So we will use Stokes law here, and the formula to find out the viscous force in Stokes law is F is equal to 6 pi into eta into r into v. So as we have to find out F here, that is equal to 6 pi, we knowing the value of the coefficient of viscosity eta, that is 1.8 into 10 raised to minus 5. The r is the radius of this raindrop, but we are having diameter, so we will take the radius, that should be equal to, it should be equal to half of diameter. So it will be 0.5 into 10 raised to minus 3 meter here, and we are knowing the value of velocity, that is v is equal to 2 meter per second. So if we put values here in this formula, then F is equal to 6 pi into 1.8 into 10 raised to minus 5, this is coefficient of viscosity, into what is r, 0.5 into 10 raised to minus 3 into velocity v is equal to 2. Next we will write here F is equal to 6 into 2, it will be 12 pi into 1.8. We can write this 1.8 as 18 divided by 10 into this 0.5, we can write this as 5 divided by 10 into this 10 raised to minus 5 into 10 raised to minus 3, it should be equal to 10 raised to minus 8 here. Next, we can write here F is equal to 12 into 5, it should be equal to 60 pi into 18 divided by 10 into 10, it will be 100 into this 10 raised to minus 8 in numerator, it will become 10 raised to plus 8 in denominator. Next we will write here f is equal to 60 into 18. It should be equal to 1080 into what is pi? Pi is equal to 3.14 divided by this 100 into 10 raised to 8. It should be 10 raised to 10. Next we will do the calculation of 1080 into 3.14 by using log. So we will write here log of 1080 into 3.14. As this is multiplication of two numbers here, so we can write log of 1080 plus log of 3.14. Next we will find out the log of 1080 here. So first the characteristics, as there is a 4 digits in integer part, so the characteristic will be 4 minus 1, 3 point. Next we will find out the mantissa here. So log of 1080 is having mantissa 0334. 0334. So this is the log of 1080, that is 3.0334 plus, now we will find out the log of 3.14. So first of all we will take characteristics here. Characteristic is what? There is a 1 digit in the integer part here. So 1 minus 1 characteristic is 0 point. Now we will take the mantissa of this 314. Then mantissa of this 314 should be 4969. Now we will do the calculation here. So 4 plus 9, it will be 13. Carry will be 1. 3 plus 6, 9 plus 1, 10 plus this carry 1, 10. We will write 0 here and carry will be 1 here. Next 3 plus 9, 12 plus this carry 1, 13. We will write 3 here and carry 1. Next 0 plus 4, 4 plus this carry 1, 5 here, and then this 3 plus 0, it will be 3. So the addition will be 3.5303, and we will find out the antilog of this now. So antilog of this fractional part, we will always find out the antilog of this fractional part. So antilog of this fractional part, 0.5303 is 3390 into, we will take this integer part as a 10 to the power. We will write this integer part as a 10 to the power here, 10 to the power 3 here, and we will take the decimal point here after the first digit. So the antilog of 3.5303 is equal to 3.390 into 10 raised to 3. So this is the answer of this calculation of 1080 into 3.14. So we will write that here. So we can write f is equal to 3.390 into 10 raised to 3 divided by 10 raised to 10 here. Now this 10 raised to 3, and here in this 10 raised to 10, the power of 3 will get cancelled, so remaining will be 10 raised to 7 here. So we can write here it should be 3.390 divided by 10 raised to 7. Next we can write here F is equal to 3.390 into this 10 raised to 7 in denominator. If we move in numerator, then it will become 10 raised to minus 7 here. So this is the answer of the viscous force, that is 3.390 into 10 raised to minus 7. But the unit of force here, as the unit of this radius, velocity and coefficient of viscosity having meter second, here it is Newton. So the unit of the force is Newton here. So the force, that is viscous force acting on raindrop, is F is equal to 3.390 into 10 raised to minus 7 Newton. This is the final answer of this numerical, and this is a total solution of the numerical. The question is, with what terminal velocity will an air bubble 0.4 mm in diameter rise in a liquid of viscosity 0.1 Newton second per meter square and specific gravity 0.9? Density of air is 1.29 kilogram per meter cube. So in this question we have to find out the terminal velocity of an air bubble having diameter 0.4 mm, and that air bubble is rise in a liquid of viscosity. Liquid of viscosity means liquid of coefficient of viscosity 0.1 Newton second per meter square, and a specific gravity of that liquid is given, that is 0.9, and density of air is given, that is 1.29 kilogram per meter cube. So first of all we will draw the diagram. See this figure here. There is a liquid is placed in a container here, and there is a air bubble in this liquid, and this air bubble will rising up. So when the air bubble is rise up, what will be the terminal velocity of this air bubble? We have to find out. So here we will write given. So in given, first is we have to find out the terminal velocity V, then the diameter of air bubble is given, that diameter is 0.4 mm. So we can write the radius is equal to 0.2 mm. It will be half of the diameter. The coefficient of viscosity of liquid is given, and that is 0.1 Newton second per meter square, and specific gravity is given. Specific gravity of the liquid is given, and this specific gravity is 0.9, and density of air is given, and here the air bubble is an object here which is moving in this medium which is liquid. So we will take the density of air as density of object, and we will write this as rho is equal to 1.29 kilogram per meter cube, and this is the density of air, that is rho is equal to 1.29 kilogram per meter cube. Next we will check the units here. So the unit of the density is kilogram per meter cube, unit of coefficient of viscosity is Newton second per meter square, but the unit of radius is millimeter here. So we will convert this unit of radius, that is millimeter into meter. So radius will be 0.2 into 10 raised to minus 3 meter here. Next, as we have to calculate the terminal velocity here and the specific gravity of the liquid and the density of the air is given, so we have to use the formula to calculate the terminal velocity as V is equal to 2 divided by 9 into R square G divided by eta into rho minus sigma. Now we are having value of radius, that is 0.2 into 10 raised to minus 3. Then we are having value of this coefficient of viscosity, that is 0.1. Then we are having value of gravity G, that is equal to 9.8 meter per second square. Then we have the value of this rho, that is density of air, and it is 1.29, but we do not have the value of this sigma here, and this is the density of the medium here, density of medium, and here medium is liquid, so this sigma is what it is, density of liquid here, and we have to calculate this density of liquid by using this specific gravity here, by using this specific gravity. Because of that we are using this formula to calculate the terminal velocity. So now we can write here the specific gravity is equal to the density of liquid divided by the density of water, So we can write here specific gravity is what it is, 0.9 into density of liquid sigma divided by density of water, and this density of water is having a constant value, and that constant value is 1000 kilogram per meter cube. So this is the constant value of density of water, which is 1000 kilogram per meter cube. So if we put here 1000, then we can write sigma, that is density of liquid, is equal to 0.9 into 1000. So we can write the density of liquid sigma should be equal to 900, and the unit will be kilogram per meter cube. So this is the density of liquid. Now if we put all the values in this formula for terminal velocity, then we can write here V is equal to 2 divided by 9. What is R? R is 0.2 into 10 raised to minus 3 square into what is G? G is 9.8 divided by the coefficient of viscosity 0.1 in bracket. Rho is what? It is the density of air, that is density of object here. So it is 1.29 minus sigma is the density of liquid, and it is equal to 900 here. Next we can write here V is equal to 2 into 0.2 square, that should be equal to 0.04 into the square of 10 raised to minus 3, it should be 10 raised to minus 6 into 9.8 divided by this 9 into 0.1, and we have to do the calculation of this 1.29 minus 900, and it should be equal to minus of 898 0.21, minus of 898.21. So 1.29 minus 900 is equal to minus of 898.21. Next we can write here V is equal to 2 divided by 9 into, we can write this 0.04 as 4 divided by 100 into, we can write this 0.1 in the denominator as 1 divided by this 0.1 should be 1 by 10 here, into, we can write this 10 raised to minus 6 in numerator. It will be 10 raised to plus 6 in denominator, and we will write here 9.8 into minus of 898.21. Next we can write here V is equal to 2 into 4, it will be 8 divided by 9 into this 0 and this 10, means the 10 and 1 0 in this 100 will get cancelled here. Now we can write this as 10 into 10 raised to 6, it will be 10 raised to 7 in the denominator, and in numerator we will write here 9.8. See here again, 2 into 4, 8 here, 8 divided by 9, this 1 of 0 in 100 and this 10 will get cancelled here. So 10 into 10 raised to 6, it will be 10 raised to 7 in denominator, and the remaining 9.8 in the numerator we'll write here, and next we will write in bracket, it should be minus of 898.21. Next we will do the calculation of this 8 into 9.8, and it should be 8 into 8, it will be 64. So we will write 4 here, carry will be 6, and then 8 into 9, it will be 72, and plus that carry 6, so it will be 78.4. So 9.8 into 8, 78.4 divided by 9 into 1 divided by 10 raised to 7 in bracket minus of 898.21. We will write here V is equal to 78.4 divided by 9, that should be equal to 8.711 into this minus of 898.21 divided by 10 raised to 7 here. Next we will write here V is equal to minus of 8.711 into 898.21 into this 10 raised to 7 in the denominator, we will write it as 10 raised to minus 7 in the numerator. Next we will do the calculation of 8.711 into 898.21 by using log. So we will write here log of 8.711 into 898.21. So as this is multiplication here, so we will write it as log of 8.711 plus log of 898.21. Now first we will solve this log of 8.711. As there is only one digit in the integer part, so the characteristic will be 1 minus 1, that should be equal to 0. Point, we have to take mantissa of this 8711. So the mantissa of this 8711 is 9400 plus we have to find out this log of 898.21 as there is a 3 digits in the integer part, so the characteristic will be 3 minus 1, that is 2 point. Now we have to find out the mantissa here. Mantissa of this 8982 and that will be 9534. That will be 9534. Now we will do the addition here and the addition will be 0 plus 4, it will be 4. Then 0 plus 3, it will be 3 here. Then 5 plus 4 or 4 plus 5 here, that is 9, and this 9 plus 9, 18, carry will be 1, and this 0 plus 2, 2 plus this carry 1, it will be 3 here. So the answer will be 3.8934, and now we have to find out the antilog of this. So antilog, in antilog we will find out the antilog of this fractional number here, that is 0.8934, and if we find the antilog of this 0.8934, that will be 7823, that will be 7823 into 10 to the power, we will write this integer part here in the power, and that should be equal to 3 here, so it will be 10 raised to 3, and we will take the decimal point after first digit here, so it will be 7.823 into 10 raised to 3. This is the answer of the multiplication of 8.711 into 898.21. Now if we write the answer here, then we can write this V as V is equal to minus of 7.823 into 10 raised to 3 into this 10 raised to minus 7. Then we can write V is equal to minus of 7.823 into this 10 raised to 3 into 10 raised to minus 7. It will be 10 raised to minus 4. It will be 10 raised to minus 4. Then we can write this V as, it will be minus of, we can write this as 0.7823 into 10 raised to minus 3. So this is the answer of the terminal velocity of an air bubble. Terminal velocity of an air bubble, and the unit of this terminal velocity will be meter per second. So the terminal velocity of air bubble is equal to minus of 0.7823 into 10 raised to minus 3 meter per second, and this negative sign here, this negative sign, it indicates that, this negative sign indicates that the air bubble rises up. So this is the final answer of this numerical, that is V is equal to minus of 0.7823 into 10 raised to minus 3 meter per second, and this negative sign indicates that the air bubble rises up, and this is the total solution of the problem. The question is, an air bubble of radius 0.2 mm is situated just below the water surface. Calculate the gauge pressure. The surface tension of water is equal to 7.2 into 10 raised to minus 2 Newton per meter. So see here, what we have to calculate the gauge pressure here, and An air bubble of radius 0.2 mm is situated just below the water surface. So first of all, we will draw the diagram here. See this figure here. In this figure, the water is placed in this container and this is air bubble here, just below the water. So this white portion here in this water is air bubble. So see here, this air bubble of radius 0.2 mm is situated just below the water surface, and we have to calculate the gauge pressure. So what is gauge pressure here? The inner pressure is Pi here and the outer pressure is P0. The pressure applied by water on this air bubble is P0 here, and the pressure inside this air bubble is Pi, and this Pi, the internal pressure of air bubble, is always greater than this pressure applied by water, that is P0. So the gauge pressure will be equal to Pi minus P0. Pi minus P0 is what? It is the gauge pressure, and we will write that in a given here. So this gauge pressure we have to find out, Pi minus P0. Now the radius of this air bubble is given, and that is 0.2 mm, and the surface tension is given here, that is T is equal to 7.2 into 10 raised to minus 2 Newton per meter. Next step is we will check the units here. So the surface tension is given in Newton per meter. Newton means kilogram meter per second square, and this radius is in mm here. So we will convert this radius in meter. So it should be 0.2 into 10 raised to minus 3 meter. Now we will find out this gauge pressure here. This gauge pressure is what? It is Pi minus P0, and this will give you the excess pressure inside this air bubble. So that can be given by here 2T divided by R, 2 into surface tension divided by R. Now if we put the values of surface tension and radius here, then we can write 2 into what is T? 7.2 into 10 raised to minus 2 divided by what is R? It is 0.2 into 10 raised to minus 3, and it is equal to this Pi minus P0, that is the gauge pressure here. So we can write here Pi minus P0 is equal to 2 into 7.2 divided by 0.2, this 10 raised to minus 2, we will write it as 10 raised to plus 2 in denominator, and this 10 raised to minus 3 in denominator, we will write it as 10 raised to plus 3 in numerator. Now this 10 raised to 2, and here in 10 raised to 3, the 2 tens will get cancelled here, so remaining will be 10 here. Now we can write Pi minus P0 is equal to 2 into 7.2 into 10 divided by, we can write this 0.2 as 2 divided by 10 here. The next step we will write here that Pi minus P0 is equal to 2 into 7.2 into 10, and this 10 is in denominator of the denominator, then it will be shifted to the numerator here, divide by this 2. This 2 will get cancelled here, then we can write Pi minus P0 is equal to 7.2 into 100, and this Pi minus P0 is equal to 7.2 into 100 should be equal to 7 20. So this is the answer of gauge pressure, and this gauge pressure is equal to 720, and the unit of this gauge pressure here, that should be, the unit of surface tension is Newton per meter and the unit of radius is meter. So we can write the unit of gauge pressure, this is pressure here, so we can write the unit of gauge pressure is Newton per meter square here, and this is the final answer of this numerical, that the gauge pressure is equal to 720 Newton per meter square, and this is the solution of this numerical. The question is, a drop of mercury of radius 0.2 centimeter is broken into 8 droplets of same size. Find the work done if the surface tension of mercury is 435.5 Dyne per centimeter. So see here, this is a drop of mercury here, and this drop of mercury is broken into 8 droplets. This drop of mercury is broken into these 8 droplets of mercury. So we will write the number of droplets are equal to 8. So these are the 8 mercury droplets. So a drop of mercury of radius 0.2 centimeter is broken into 8 droplets. So we will take the radius of this drop of mercury here, that will be capital R, and it is equal to 0.2 centimeter here, 0.2 centimeter, and after that we have to find out the radius of the small droplet here, radius of small droplet. So we can write here the volume of single drop of mercury is equal to the volume of n droplets. So as this drop is spherical, we can write the volume of single drop, that should be equal to 4 by 3 pi r cube is equal to the volume of n droplets. So the volume of this single small drop here, that should be 4 by 3 pi into small r cube, because small r is what? It is the radius of this small drop. But we have to find out the volume of n droplets, so we will multiply this by n here. Now this 4 by 3, this pi will get cancelled, so we can write here r cube is equal to n into r cube here, small r cube. If we take cube root on both sides, then we can write capital R is equal to n raised to 1 by 3 into small r here. So as we have to find out the small r, then small r is equal to, we can write capital R divided by n raised to 1 by 3. If we put value of capital R here, that is in centimeter, so we will convert this in meter here, because we have to find out the work done. So we can write 0.2 into 10 raised to minus 2 meter here. So if we put the value of capital R here, then it is 0.2 into 10 raised to minus 2 divided by, what is n? N is 8. So 8 raised to 1 by 3. 8 raised to 1 by 3. Then we can write here small r is equal to 0.2 into 10 raised to minus 2, 0.2 into 10 raised to minus 2 divided by the cube root of 8. This 8 raised to 1 by 3 means the cube root of 8 is equal to 2. Then we can write here the small r is equal to the 0.2 divided by 2, it will be 0.1 into 10 raised to minus 2 and the unit will be meter. So this is the radius of the single drop. Radius of the single drop. Next step we will do, what we have to find out work done. So here this work done should be equal to T into dA, that is surface tension into change in area, that is dA. So in given here we can write surface tension is 435.5 dyne per centimeter. 435.5 dyne per centimeter, that is given in the problem here. So we have to convert this surface tension in Newton per meter here. So we can write here this T, that is surface tension, is equal to 435.5 into what is 1 dyne. 1 dyne is equal to 10 raised to minus 5 Newton. 10 raised to minus 5 Newton. And what is 1 centimeter is equal to how many meters? Then it will be 10 raised to minus 2 meter here. So we can write this surface tension T is equal to here 10 raised to minus 2, then it will be here remaining 10 raised to minus 3. So we can write this as 435.5 into 10 raised to minus 3 Newton per meter here. So this will be the surface tension of the mercury in Newton per meter. And what we have to find out? We have to find out the work done here, that is dW. The next step we will do, that is we will find out the change in surface area here, that is dA, and this change in surface area, that should be equal to the final surface area minus initial surface area. So the final surface area should be here n into 4 pi r square. 4 pi r square is the area of the sphere here, and as there are n number of droplets here, so we will write the final surface area of the mercury should be equal to n into 4 pi r square minus the initial surface area, that should be equal to the surface area of this single drop, and that is 4 pi capital R square here. So we can write dA is equal to, that is change in surface area, is equal to, if we take 4 pi common here, then we can write nr square minus capital R square. Now if we put the value of n, small r and capital R here, then we can write dA is equal to 4 pi, what is n? N is 8. What is small r? It is 0.1 into 10 raised to minus 2 square minus what is capital R? It is 0.2 into 10 raised to minus 2 whole bracket square here, and we will complete the bracket. Next we will write here dA is equal to 4 pi in bracket 8 into what is the square of this 0.1, that will be 0.01 into the square of 10 raised to minus 2, that should be equal to 10 raised to minus 4 minus the square of this 0.2, it will be 0.04 into the square of this 10 raised to minus 2 will be 10 raised to minus 4, and we will complete the bracket here. Next we can write here dA is equal to 4 pi. If we take 10 raised to minus 4 common here, then we can write here 10 raised to minus 4 in bracket 8 into 0.01. That should be equal to this 8 into 0.01, that should be equal to 0.08 minus 0.04. Then we can write here dA is equal to 4 pi into 10 raised to minus 4. This 0.08 minus 0.04, that should be equal to plus 0.04 here. Next we can write dA is equal to 4 pi into 10 raised to minus 4 into this 0.04, we can write this as 4 divided by 100 here. Then we can write dA is equal to this 4 pi divided by this 10 raised to minus 4, in denominator it will be 10 raised to plus 4 into 4 divided by 100 here. Then we can write this dA as 4 into 4, it will be 16 into pi divided by this 10 raised to 4 into 100. 10 raised to 4 into 100, it will be 10 raised to 6. It will be 10 raised to 6. So what is dA here? dA is what it is? 16 pi divided by 10 raised to 6. Next step we will do, that is we will put the values of T and dA in this equation of dW is equal to T into dA. So if we put values of T and dA in this equation of dW, then we can write this dW is equal to, what is T? T is 435.5 into 10 raised to minus 3 here into what is dA? dA, see this, dA is what it is? 16 pi divided by 10 raised to 6. 16 pi divided by 10 raised to 6. Then we can write this dW as 435.5 divided by this 10 raised to minus 3, we can write this as 10 raised to plus 3 in denominator into 16 pi divided by 10 raised to 6. Then we can write this dW as 435.5 into 16 pi divided by this 10 raised to 3 into 10 raised to 6 will be equal to 10 raised to 9. Next we will write here dW is equal to 435.5 into 16 into pi is what it is, 3.14 divided by 10 raised to 9. Next we will do the calculation of this 435.5 into 16 into 3.14 by using the log table. So we will write here the log of 435.5 into 16 into 3.14. So when there is a multiplication, there is an addition in log here, so it will be log of 435.5 plus log of 16 plus log of 3.14. Now we will first find out the log of 435.5 here, and this 435.5 having 3 digit in integer part, so we will take first characteristics that should be equal to 3 minus 1. As there is a 3 digit in integer part here, so we will take the characteristics as 3 minus 1, that should be equal to 2 point. We will take the mantis of this 4355 from the log table, and that mantis is equal to 6390 plus. Now we will find out the log of 16 here. So here in integer part there are 2 digits, so the characteristic will be 2 minus 1, it is 1, and the mantis of this 16, that should be 2041, that should be 2041 plus. We will find out the log of this 3.14 now. So there is only 1 digit in integer part, so the characteristic will be 1 minus 1, 0 point. We will find out the mantis of this 314 here, and that mantis is 4969. Now we will do the addition of this. So 0 plus 1 1 plus 9 10, so we will take 0 and there will be a carry 1 here. Next 9 plus 4 13, 13 plus this 6 19 plus this carry 1 20, so we will write 0 here and there is a carry 2. Next is 3 plus 0 3 plus 9 12 plus this carry 2 14, we will take 4, there is a carry 1 here. Next 6 plus 2 8, 8 plus 4 12 plus this carry 1 13, so we will take 3 here and carry 1. Next 2 plus 1 3 plus 0 3 plus this carry 1 4, so the answer is 4.3400. Now we will find out the antilog of this. So to find out the antilog of this, we always consider only the fractional part. So we will take the antilog of this point of 3400 here. So the antilog of point of 3400 is 2188 into, we will take the integer that is 4 here as a 10 to the power here. So we will write here 2188 is the antilog of this point of 3400, and we will take this integer 4 as a 10 to the power here, and we will take the decimal point after the first digit, so it will be 2.188 into 10 raised to 4. So this is the answer of this 435.5 into 16 into 3.14. Now we will write this answer here. So we can write dW is equal to 2.188 into 10 raised to 4 divided by 10 raised to 9. So this 10 raised to 4, and here 4 will get cancelled, so remaining will be 5 here, remaining will be 5. So we can write here dW is equal to 2.188 divided by 10 raised to 5. Then we will write dW is equal to 2.188 into this 10 raised to 5 in denominator, it is 10 raised to plus 5, but if we shift this in numerator, then it will be 10 raised to minus 5. So this is the work done, that is 2.188 into 10 raised to minus 5, Now see the unit here. As the surface tension we are taken in Newton per meter and the area, that radius we are taken in meter. So we will write the unit of work done is joule here. So the final answer is the work done dW is equal to 2.188 into 10 raised to minus 5 joule. So this is the solution of this numerical. The question is, how much work is required to form a bubble of 2 centimeter radius from the soap solution having surface tension 0.07 Newton per meter. So here we have to find out the work required to form a bubble of 2 centimeter radius from the soap solution. So we will draw the figure first. See this figure here, this is a soap bubble. This is a soap bubble of radius 2 centimeter. Radius 2 centimeter. So here small r is the radius of this soap bubble and that radius is 2 centimeter. So what we have to find out? We have to find out the work required to form this soap bubble of 2 centimeter radius. So we will write G1 here. So in G1, first we will write, we have to find out the work, that is dW. Then the radius of bubble is given, that is 2 centimeter. Next, the surface tension is given, that is 0.07 Newton per meter. Now we will check the units here. So the surface tension is having unit Newton per meter. Newton means kilogram meter per second square. Then we have to convert this radius. Now we will convert this radius in meter here. So we can write here 2 into 10 raised to minus 2 meter here. After that, we will use the formula to calculate this work done or work to form this bubble here. So that work is equal to dW is equal to T into dA. dW is equal to T into dA. We are having value of surface tension T, but we have to find out the surface area of this soap bubble. So as this is a soap bubble, so this soap bubble having two surfaces. One is inner surface and second one is outer surface. So if we have to find out the surface area of this bubble, as it is spherical in shape, then we can write dA is equal to, it will be 4 pi r square. But as this soap bubble having two surfaces, one is inner, second one is outer, then we have to multiply this by 2 here. Now if we put the value of r here, then we can write dA is equal to this 4 into 2, it will be 8 pi into what is r, 2 into 10 raised to minus 2 square. Then we can write dA is equal to 8 pi into the square of 2, it will be 4, into the square of 10 raised to minus 2, it will be 10 raised to minus 4. Next we will write here dA is equal to 8 into 4 is what? It is equal to 32 into pi into 10 raised to minus 4. Now we will put this value of dA, that is 32 pi into 10 raised to minus 4, and the value of T, that is surface tension 0.07, in this formula of dW. So if we put the value of T and dA here, then we can write dW is equal to, it will be, what is T? 0.07 into what is dA? It will be 32 pi into 10 raised to minus 4. Next we will write here dW is equal to, we can write this 0.07 as 7 divided by 100 into 32 pi divided by this 10 raised to minus 4 is in numerator. So if we write this in denominator, then it will be 10 raised to plus 4 here. Then we can write dW is equal to, what is 7 into 32, then it will be 224 into pi divided by this 10 raised to 2 into 10 raised to 4, it will be 10 raised to 6. Next we will write here dW is equal to 224 into, what is pi, 3.14 divided by 10 raised to 6. Next we will do the calculation of these 224 into 3.14, and this we will do by using the log. So we can write here log of 224 into 3.14. So as this is multiplication here, so we can write this as log of 224 plus log of 3.14. So when there is a multiplication between any two numbers, then in log there will be an addition in terms of log between the two numbers. Now next is we have to find out the log of 224 here. So first we will take characteristics here. See here, in integer part there are 3 digits. So 3 minus 1, it will be 2. So this 2 is the characteristic here, and next we will find out the mantissa. Now the mantissa of this 224 will be 2 point here 3502. 3502 is what? It is the mantissa of this 224. Plus next we will find out the log of 3.14. So first of all we will take characteristics. So in integer part there is only one digit here. So 1 minus 1, characteristic will be 0. Next we will find out the mantissa of this 314, and that mantissa is 4969. 4969. Next we will do the addition here of this. So 2 plus 9, it will be 11, and carry will be 1. Next 0 plus 6, it will be 6 plus this carry 1, then it will be 7 here. Next 5 plus 9, 14, so we will write 4 here, carry 1. Next 3 plus 4, 7 plus this carry 1, 8 here, and then we will write this 2 plus 0, it will be 2. So the addition will be 2.8471, and we will find out the antilog of this. See here, we always find out the antilog of this fractional part here, and the fractional part is 0.8471 here. So antilog of this 0.8471, it should be equal to 7033 into this integer part. We will write this 10 to the power, so it will be 10 raised to 2 here, and we will take the decimal point after the first digit. So the answer of this 224 into 3.14 is 7.033 into 10 raised to 2 here. So if we write this here, then we can write dW is equal to 7.033 into 10 raised to 2 divide by 10 raised to 6. So here this 10 raised to 2 and here 2 will get cancelled, so remaining will be 4. So we can write here dW is equal to 7.033, this 10 raised to 4 in denominator, in numerator it will be 10 raised to minus 4, and this we can write it as dW is equal to, if we write this as 0.7033, then we will write power here 10 raised to minus 3. Now unit of this work, as the unit of radius is meter, surface tension is Newton per meter, so unit of work is joule here. So this is the final answer where we have to calculate the work here, and the work is 0.7033 into 10 raised to minus 3 joule, and this is the whole solution of this numerical.